Good morning, good afternoon, good evening from whichever location you are seeing this video. In this tutorial, we'll be learning database normalization. So this tutorial is database normalization for beginners. So it is a 30 minutes of tutorial, and in this tutorial, I'll be first walking you through the basics of first normal form, second normal form, third normal form, and so on. And while I'm doing so, I'll be explaining you the different database design problems, we come across and how these normal forms actually helps us. And also I'll be talking about the difference between duplicate and redundancy. Many people think that both of these terms are same, but they are different as well, right? So I'll be explaining the difference between these two concepts as well. And also I'll be talking about partial dependency, transitional dependency. I'll explain you what is atomic and repeating groups. So this is going to be a 30 minutes of tutorial which will make you understand database normalization. So let us get started. Database is like a fort. It's like a fort, and one of the main goals of this fort is that redundant data, bad data, duplicate data should not enter the system, or your system should not have any one of these. Second, the end user should also be able to trust the data, right? In other words, there should be data integrity, your data should be really useful, and so on, right? So for that, the first important thing is that how is your database design? What kind of database design principles are you following, right? So what we will do is, before we go into first normal form, second normal form, third normal form, let us first try to understand that what are the basic database design mistakes people make. Once we understand those design mistakes, then it is very easy to understand first normal form and second normal form and so on, right? So the first mistake which developers make is that they do not put proper primary keys, they do not put proper candidate keys, they do not put proper unique keys. For example, now look at this. I have this table here, TBL customer. In this TBL customer code should not be duplicate. Very simple, right? So if you see here at this moment, if I go and put some duplicate records, it does allow me, right? So you can see here, I'll say this is Raju, and you can see that it does allow me to enter duplicate records. Now this is bad. Customer code should be unique. So in other words, the first thing and a very basic thing what you should do is that you should have a primary key. You should put proper unique keys on fields which are needed. For example, in this case, you should have a unique key or a primary key on the customer code, right? So we can resolve this issue by putting a proper primary key or proper unique key. So if you see here, I can go to the design and I can say that this customer yeah, this customer code, I want it to be unique. So I can go and add unique yes on the customer code. So you can see customer code, I want it to be unique, right? I don't want any index on this as such. I just want it to be a unique key, right? So with this, now what will happen is, now, people cannot put duplicate records in my customer code. So the first thing what you need to follow is that you need to put proper unique keys, proper primary keys, right? So you can see now I'm getting an error here saying that no, you are now violating the uniqueness of the customer code. So the first database design mistakes what people make is that it's very basic one. They don't put a primary key. They don't put appropriate candidate keys. They don't create unique keys, right? So that's the first design mistake. The second database design mistake what people do is, and I would say this is not a mistake, but it is more of a lethargic approach. They try to put multiple values into single columns. Now people need to understand that this is a column. It's a single value. It has to have atomic values. It is not a wall. It is a column, right? So basically a column, a pillar has only a single thing. But people try to do like this. They will say, okay, let's say that this customer buys multiple products. So people do like shoes, comma, tie, comma, pen. right? And then there are smart people who probably do not use commas, they use pipes, but they use some kind of weird separators, right? So some of the people use pipes, right? But now think about this. If you try to store data in this format, you can have problems, right? It is possible that you can put duplicate data. For example, I can put shoes, ties, and shoes, because this is like a free text, isn't it? So over here, the rule which we need to follow is that one column should store only single value, atomic value, means value which cannot be divided any further. Okay. So in order to resolve this, people again use another lethargic approach. They create two columns. So they say, oh, so we need 3 values to be stored, right? 3 products. So what they do is they go here, they design that table and then say, okay, this is product 1, this is product 2, and this is product 3. They do like this, and then they go here and they say, okay, so this first one is shoes, the second one is socks, the third one is pen. Again, this is lethargic approach, right? But now there are problems with this approach, right? For example, now let me enter one more record. So let me enter Raju 1002, some phone number, some social security number, and let me say that he just buys a pen, right? Now let me enter something test, okay, 1009, something here, right? And he buys shoes, he buys socks. Now we have problems here. The problem here is redundancy, redundant data. Now before we proceed ahead, it's very important to understand the difference between duplicate data and redundant data. Sometimes back we discussed about duplicate data. Must be for a lot of people who are specially coming from vernacular medium, for them redundant and duplicate are same vocabulary, but they are not same. Let me spell out, or let me go and flash 2 sentences on the video, and these 2 sentences will probably tell you what is the difference between duplicate and redundant. Look at the first sentence. Please print a duplicate copy of this bill. Again, I repeat the first sentence. Please print a duplicate copy of this bill. Now look at the second sentence. You have a redundant power supply. Again, I repeat the second sentence. You have a redundant power supply. So duplicate means exactly same. Like when you do a kind of a photocopy, or probably you keep a backup. So at that time, exactly everything is same as it is. But redundant means that it is something extra. It is not exactly same, but it is something extra. Probably it is there for backup purpose. So duplicate and redundant are 2 different things. If you see out here, our fields, that is product 1, product 2, product 3 are actually redundant fields. But if you remember, sometimes back, when I typed here 1001, both of these are duplicate records. So these are duplicate records, but these are redundant extra fields. If you see the first row here, in the first row, we have shoes, socks, and pen. Look at the second one. We have pen, and we do not have any other products for this second customer, so we have just put null. Look at the third one. In third one, we have just 2 products, so the third column is null. So you can see over here, for the second and the third record, there are some columns null. They are just lying out there. They are redundant. They are extra. Probably they are of no use. So because of our bad design, we have entered into something called as redundant problem. This problem is also technically termed as repeating groups. Repeating groups means you have created columns, which are exactly same, like product 1, product 2, product 3. And these columns are created in a very, very unorganized manner. In other words, why is this field product 1? Why is this product 2? Why is this product 3? No one knows, right? So this sequence makes no sense as such, right? Why? Because they are just redundant fields. And tomorrow, let us say that if you want to add product 4, then you have to go and change the database design. So again, this repeating groups actually brings you in a very strict design, right? So it's not flexible as such. So in order to remove this repeating group problems, what we really need to do is we need to go and create one more table called as a product table. In other words, what we are doing here is now we are going to go and split this table into two tables. One table which will have the customer records and the other table which will have the product records. This splitting of tables into two is termed as normalization, right? So I'm going to go and create a table here. So let me go and create a table which will be a product table. So it will have a product ID. And let me also put something here that this product will also have a model. So in other words, you have a product and what kind of model it is, right? So let me just put some extra columns here. And in this table, I will make both of this as a primary key, a composite key, right? So there is a product and there is a model. It's a composite key here. So one is that we will have here a product name. We will have the model name, right? We will have the manufacturer, who manufactured this product and model. So manufacturer name, right? So I am creating a new table here altogether called as TBL product, and in this I will go and make all the entries, and this table will have a foreign key relationship with the TBL customer table. So in other words, from the TBL customer table, I'm going to go and remove both these all fields from here because these are actually repeating groups. So I'll delete this column, and over here I will put a product ID FK. Now what we will do is henceforth, in this tutorial, if you have a foreign key, I will name it as underscore FK so that we know that this is a foreign key, right? And also I will have a model ID underscore FK. So remember that the primary table there has a composite key. So that's why I've created a composite key out here, right? So there it is. So I can go to my database diagram and just let's go ahead and define the relationships. So there it is. And now I can go here and say that these two are foreign keys. So here it is. Save it. So now you can see in the product table, I have entered two products, 101 and some model number, 102 and some model number and product name, so you can see now I have a separate table where everything is defined, and then I can link that to the customer. So over here in the customer, now I can go and say, okay, the first customer buys 101 and 908. The second customer buys must be 102 and what is that? 909. But again, this design is not what we are expecting, because what we were trying to do when we were doing redundant fields is one customer can buy multiple products. So you can see here we just have one field, right? This does not make sense. So in other words, we need to create one more intermediate table which will have reference of the customer ID from this table, and it will have a reference of the product ID and model ID from this table. In other words, we need to create a table which is having many-to-many relationships. Please note, at this moment, by putting the columns in this customer table, what we have done is we can just enter for one customer, one product, which is not what exactly we wanted to do, right? We wanted to actually say that, okay, one customer can buy multiple products and multiple products can be bought by multiple customers, isn't it? So basically this design is not what we are expecting. So let us go ahead and make this design proper. So first thing is, let us remove both the fields from here. And let us create one table which will have the many-to-many relationship. So we can name that table as TBL product customer, right? So I'm going to go and create a table here, which is going to have product and customer ID, right? And this will also have the reference of the customer ID, right, from the customer table. So it will say that this customer has bought this product of this model. Remember, whenever I'm saying underscore FK, that means it's a foreign key, right? So this we can name it as TBL product customer table. So this is the many-to-many table. Okay, so I'm going to go back here and I will just say, just add that table TBL product customer. So look at this. This table will have the customer ID from here, and it will have the model ID and product ID from here, right? So in other words, this is a many-to-many relationship. If you see in the previous video, we saw one-to-many relationship, but over here, one customer can buy multiple products of that model, and multiple products can be bought by multiple customers. So many-to-many relationship. So in other words, now this makes my life easy. So over here now, we can see that we have customer ID 1, Shiv. So Shiv has bought, so I can say here, Shiv has bought 1. He has bought 101 and model ID 908, 101 and model ID 908. And again, Shiv has bought the second product, which is 102 and 909. Now you can see this is flexible, isn't it? If you look at the repeating groups, where we were adding column wise, now we are adding row wise. And this is not even redundant. In other words, if I think that there is no second product, I can just delete it. It does not occupy space. There is nothing redundant out here. Good. So we talked about 3 things till now. We said that first thing is duplicate data issue is removed by creating properly the primary keys, by creating properly the unique keys, the candidate keys. Problem number 1, duplicate data. Second, we said that in a single column, we should have single value, atomic value. We should not have multi-value rows, right? So in other words, we cannot have product 1, product 2 as we did previously. Third, we said that we should not have redundant columns, repeating groups, right? When you go and satisfy these 3 rules, if you create a primary key, if you ensure that you do not have multi-values in a single column, right? In other words, your column is having an atomic value. When I say atomic value, means it cannot be divided any further. And third, when you ensure that you do not have repeating groups, that means you have implemented first normal form. First normal form says all of these 3 rules. The fourth design mistake which a lot of developers do is their non-key columns. Non-key columns means, for example, this product name, product cost, model name, model brand, and so on, means columns which are not primary key do not depend fully on the primary key. In other words, at this moment, we have a composite primary key here of product ID and model ID. If you see, this product name and product cost is dependent on the product ID field. If you see, the model name, model brand is dependent on the model ID. In other words, this model has nothing to do with the product directly as such. This product has nothing to do with the model directly as such. Getting it? So over here, what is happening is the non-key columns are partially dependent on the composite key. Now, this is a bad design. Why? Because when you say a table is a logical unit. If you are putting fields which are not related to that unit, then you have problems, right? So in other words, tomorrow if you want to add or remove fields, then it becomes very difficult to change the structure, because in one table you have put a lot of entities, right? So we need to go and remove the fields, which are not really belonging to this product table. So if you see this model name, model brand, manufacturer, country and area and so on, they are not really connected with the product as such, and they should be moved to a different table, right? So what we can do out here is we can go ahead and create a table, and in this table I will have a model ID. Now a lot of changes will happen. So this is the model ID, that is a primary key. So this model name model brand, so all this goes to the TBL model table, TBL model, right? And all the other fields can be removed from here. So over here now I can get rid of this model ID. I can get rid of everything what is related to model. All right, and this is the product ID. And I'll save this. Now if you see out here, this product table right out here, the product table what you're seeing out here is only having product related information. You can see the model table, it is only having the model related information. So it is very important in order to have a proper logical design that all the non-key columns should depend fully on the primary key. If they are not dependent on the primary key, that means that in one table you are having multiple entities. For example, if you see the previous scenario, in the product table we had the model entity as well as the product entity. And tomorrow when we want to change the model, we have to also change the product, right? Now this also leads to a lot of changes in our database diagram, right? So let us go ahead and put all the tables and let's see that what kind of changes do we have to make here. So first thing is now this product ID will come from here and the model ID will come from a separate table. You can see that every time we are trying to tackle the design problem, we are splitting the tables, right? And the model ID comes here. So remember, normalization is all about splitting your tables into smaller units, into smaller manageable logical units. There is some problem here, must be because of the data. Let's save this. It says foreign key constraint. Yeah, because the model table is not filled now, right? So we need to go and fill the model table. So the model has 908909, so I can go and fill the model table. So 908, some model 1, some brand, right? Test India, Punjab. We also were having some other data. TBL product 909, model 2, some other brand, test 1, US, right? So you can see now my model table is different, my product table is different. This is termed as second normal form. In second normal form, all the non-key attributes, or I will say non-primary columns or non-primary attributes, are fully functionally dependent on the primary key. So if you remember in the previous table design, the model was dependent on model ID but not on the product ID. The product was dependent on the product ID but not on the model ID. So that led to the split of the tables. And for second normal form, all the previous three things of the first normal form should be satisfied. So to be in the second normal form, all the previous first normal form rules should be satisfied. That means the value should be atomic, there should not be any repeating groups, and you should have a primary key. Now let's talk about the fifth design problem. This fifth design problem, you can term it as transitive dependencies. Means what? For example, if you look at this model table, in this model table, this area over here is dependent on the country and not the model ID. So if you see here, this area here depends on the country. So for example, if I type Nepal here, then depending on what the value of the country is, the area is entered, right? So in other words, this area value is dependent on the country. Again, this is bad, right? Why? Because as we said, a table is a logical unit. It should not have too many entities in it. So in this model table, if you see, we have one more entry here, which is country and area. So must be, again, these two things should be moved out separately, right? So in other words, what we should be doing is we should create one table called as country, right, with a country ID, and in that we should have the area, right? So something like this, right? So must be, we should create a new table, country ID. Remember, always keep a primary key so that your design is always in the first normal form. So TBL country, and we can have one more table called as TBL area. So area ID, area name, right? Now one country can have many areas, isn't it? So what we can do over here is must be in the area table itself we can have a country ID. So so in this country, in this area table, we can have a country ID FK, right? So for, well, if you see out here, so country ID underscore FK, we will keep it at this moment as it is, because this is not a perfect design, but still it is fine. So now what I will do is over here, I will have my country like 1 India, 2 Nepal, 3 US, right? And then what I can do is in the product table, in the model table, I don't need both of these keys. I can delete them. And what I need out here is only country ID underscore FK. So over here, I will now go and just say 1, 2, 3, right? So I don't have to refer the, so over here, I'll just say that this is on country India, this is on Nepal, this is on US. So you can see now in this table, it is only related to the model. So what is the model name, who is the manufacturer for the model, and where it is manufactured, and other things are on separate tables. So normalization means it's a technique, where we go on splitting the tables. Okay, so we try to split the tables logically, and whatever is the logical data resides in one table. So third normal form says that, this is the third normal form. Third normal form says that there should not be any transitive dependency. If you remember in the previous table design, one non-primary key attribute was dependent on the other non-primary key attribute. It should depend on the primary key, right? This is called as transitive dependency. And when you remove transitive dependency, that means you are in the third normal form. So this is the fifth thing, right? So there are 5 design mistakes, and for all those 5 design mistakes, there are solutions, where we have first normal form, second normal form, and third normal form. So let's summarize, what we have learned. So we said that developers make 5 big design mistakes. They do not put a primary key. So if they do not put a primary key, if they do not put proper unique keys, right, it can lead to duplicate data issues. Developers try to stuff multiple values into one columns, that leads to duplicate data, update problems, delete problems, because now your values are comma separated and pipe separated. Repeating groups, people just create multiple redundant columns, and that leads to redundant data. Remember, product 1, product 2, product 3, some things were null, some things were not null, right? Partially dependent on primary key, again here we can have redundant issues and integrity issues. And then transitive dependency, wherein one non-key column depends on the another non-key column. So rather than depending on the primary key, these non-key columns are dependent on another non-key column. So in that case, again, we have redundant and integrity issues. So when we resolve the first 3 design mistakes, so I'll just go and merge this format cell. So if we resolve the first 3 design mistakes, right, then we can say that you are in first normal form, or you're following first normal form, right? First normal form. When you resolve the 4th design problem, so when you resolve the 4th design problem, you're also resolving all the top problems, right? So this is more of cumulative. So this is second normal form. So you are in second normal form. And when you go ahead and also remove the transitive dependencies, then you are in third normal form. For to be in second normal form, you should satisfy everything of the first normal form. To be in third normal form, the first and second normal form should be satisfied, right? So normalization is nothing but it is a technique, wherein we go and we start breaking the tables into multiple logical tables. So if you remember, when we had repeating groups, we broke the table. When we had partial dependency, we broke the table. When we have transitive dependency, we broke the table. So normalization is all about splitting tables into smaller logical pieces and putting data into logically one table, so that when you modify that table, the other table does not get affected. Also, a lot of people, to remember first normal form and second normal form, a lot of people also use this kind of notation, one word, or one sentence, where they say that first normal form means it should depend on a key and it should be atomic. First normal form. Second normal form says that it should depend on the full key. And the third normal form says that it should depend only on the key. This is, just in case if you forget, right? So you can remember from the key perspective, primary key perspective. First normal form says that it should have a primary key. There should not be any repeating groups. Second normal form says that it should be dependent on the full key and not the partial key. And the transitive dependency says that, or third normal form says that, only on the primary key and nothing else, right? So that brings us to the end of this video. I hope that you enjoyed this video. And after this, we will have a slide which is of revision. So please go through the questions and try to answer those questions yourself and see that if you have understood the topic. Thank you very much.